Okay, so last week we talked about data distributions, and this week we're going to start talking about the main ways that we describe data distributions. So there's three main ways of describing data distributions. One is the center, which is the measure of where the center of the data is. Two is the spread of the data. And the third are things like the shape and skewness of the data. We're going to go into each one of these in a bit of detail. So say we have this distribution of 1, 2, 3, 3, 4, 5, 8. I've plotted them here on this line. The measure of, we could plot them and look at them, but we need numerical ways to describe them. So the main measure of central tendency that you will encounter is the arithmetic mean. This is the most common and the most useful. The definition of the arithmetic mean is you add up each of the sampled numbers and divide by the total number. In this case, it would be 1 plus 2 plus 3 plus 3 plus 4 plus 5 plus 8 plus 9 divided by 8, 4.37. 4.37 is the mean of this particular data set. The second possible measure of central tendency is something called the median. The median is at times very useful for data sets that are skewed. And that's because the median is less subjective to pull from the outliers. In most statistical tests, you'll end up using the mean, but you will see the median talked about in some cases, and it's important to know why it's a good measure. It's less subjective to pull from outliers because the mean is defined as the middle number when things are sorted. You'll probably encounter this when you look at box plots as well. So the middle number when things are sorted means that if you go 1, 2, 3, 3, 4, 5, 8, 9, well, there's 4 and 4, so right in the middle at 4.5, or what right in the middle, which is halfway where I'm putting my mouse, that's where the median is going to end up being at 3.5. Usually it is the middle number because we have an even number of data points here. The median becomes the halfway point between the middle two, so 3 and 4. So it ends up being 3.5. And finally, we have the mode, and that is the value that occurs the most often. It's the value that has the highest probability of occurring, if you talk about it in a different way. It's not as useful, but you will see it talked about from time to time. It's used less often. And you could see that the mode for this is 3 because 3 is used twice, and it has the highest probability of occurring based on the fact that it's used the most. And so here we see that this data set is kind of skewed, right? We have some outliers here, 8 and 9. Those outliers are pulling the mean and the median far from the mode. So let's talk a little bit about symmetrical distributions and asymmetrical distributions. So for a symmetrical distribution, the mean is going to equal the median is going to equal the mode. But what about when a distribution is skewed? So this is a skewed distribution. It's skewed to the right, or it is positively skewed. So for a skewed distribution, the mode is still going to fall at the top of the probability distribution because that is the data point that is most likely to occur. So when you take lots and lots of samples, that's the one you're going to end up with the most of. The median is going to divide the density curve in half, so that half of the weight will be on one side of it and half of the weight will be on the other side of it. This is because when you take enough samples and then count up and go halfway in between the two, you'll likely come somewhere around the true median, which is halfway down the probability density curve. It's a better measure of central tendency when the data set is skewed. And that's because the mean is the balance point. But balance points are a tricky thing. They can be extremely sensitive to very extreme results. So why is the mean further from the mode than the median? And that's because things that are really far away tend to pull it harder than things that are closer. So if a value is in this big area here where the mode is, right, that's only this far away from the mean. And so when you add it up, this value will pull the mean less hard than a very low likelihood outlier that's very far away that's going to pull the mean much harder because its distance from the mean is larger. All right. So what about for discrete distributions? So we'll go back to our dice example. For a discrete distribution, the mode is going to be the highest probability result, just like for the continuous distribution. For a six-sided die, there's equal chance of each of the 6 sides. So for a six-sided die, there's essentially 6 modes because it's flat. But for a weighted die that has a 51% probability of rolling a 3, the mode will end up being 3 because that is the peak on the or the highest probability outcome in the discrete distribution. For the arithmetic mean, it's the sum of the probability of all of the possible outcomes multiplied by their value. It's represented like this, the value multiplied by the probability. So for our 6-sided die, it's 1/6 times 1, 1/6 times 2, 1/6 times 3, 4, 5, 6, and that comes out to what you would expect. The arithmetic mean of a 6-sided die is 3.5. The median of the 6-sided die is the value for which the probability of the probability of occurring is less than that particular number that's selected, is greater than or equal to 0.5, and the probability of that number being less. So the probability of it being less than that particular number is greater than 0.5, and the probability of that number being greater than the number you select is also greater or equal to 0.5. This is a mouthful and a lot to think about. It does make sense when you think about it for long enough, but don't worry about this one. We won't talk about, we won't really have to do that in this class, but I thought I would at least mention it. Okay. So we talked about measures of center. Let's talk about measures of spread. There are 2 main ones that we'll deal with in the class. There's a couple more we'll introduce later, but let's focus on these first 2 first because they are the foundation for everything else. Variance is how far the data is spread from the mean. So variance is the average of the squared differences. So that means if our mean is 4.375, and we were looking at our data set that we had before, we would sum up 1 minus 4.375, 2 minus 4.375, 3 minus 4.375. Each one of these things squared divided by the total number is going to equal the variance. And so for this particular population, the variance is 6.98. And that's good. Now we have an idea of how far the data is spread from our mean. But it's not that good because the mean's units are whatever units we were working in, the variance's units are whatever units we were working in squared. So most of the time you'll see things written in the standard deviation. The standard deviation is simply the square root of the variance. And that's useful because now the standard deviation is in the same units as the mean, is in the same units as the data that's being sampled. And so the square root, so the standard deviation of this data set that we're looking at is 2.64, which can be plotted on the same axes as the mean, and I did that so here in purple. So aside from this being a measure of spread, it becomes even more meaningful once we start looking at the normal distribution. So for the normal distribution, which we'll look more into next class, 68.2% of the data falls within 1 standard deviation of the mean. 95% of the data falls within 2 standard deviations from the mean, and 99.7% data falls within 3 standard deviations from the mean. For known distributions like the normal and exponential and F distributions, all of these values are worked out. So when you know what the standard deviation and the mean is, you have a really good idea as to what the probability of sampling any particular value becomes. And this will be very important for when we start to run statistics in a few lectures here. All right, so what about for discrete data distributions? We'll go back to our dice again. So to calculate the variance of a dice roll, we would simply take the each number, subtract it from the mean, square it, just like we were doing with continuous distributions, and then multiply it by the probability of that particular outcome occurring. So in this case, a 1 has a 1/6 chance. You multiply it by 1 minus 3.5 squared. You add all of these up, and you end up with the variance of a dice roll. But you didn't know you could calculate a variance of a dice roll, but you can. And because the variance isn't very useful, we instead look at the standard deviation. And so the standard deviation of a dice roll is 1.71. And you'll maybe be thinking in your head, well, like, what does that mean that, 60% of the dice rolls fall between 2 and 4? Not necessarily, because this is not going to form a normal distribution. It's a flat distribution because there's 1/6 for each of these things. So it doesn't actually mean what we said for the normal distribution, because it is not in a normal distribution. But it is still the main measure of spread that you'll see for any particular data set. All right, so finally, let's talk briefly about shape. We talked a bit more before about a positive skew. For a symmetrical distribution, the mean, the median, the mode are identical. For a positive skew, that means there's a long tail in the positive direction. That means the median will be pulled to the right, and the mean will be pulled even farther to the right. The mode will still be where the highest probability is. For a negative distribution, which means the long tail is in the left or in the negative direction, the median will be pulled in that direction, the mean will be pulled even further. And we've talked about why that is earlier. The second piece of terminology I would keep in mind is bimodal. Bimodal simply means that there's two modes, so bimodal, two peaks of the probability distribution. You could have trimodal or multimodal, but bimodal is what you'll most often hear. All right, so these are our basic terms for how we will describe data distributions in the future.